Hi, this is Pre-Calculus Unit 1, and we're doing 1.4, where we are looking at quadratic generators. So previously, we saw something like this. This is what we call an arithmetic sequence. Why this is an arithmetic sequence is because what we have is a common difference. And so when we're looking at these things, I have the difference between 2 and 5 is a 3, and the difference between 5 and 8 is a 3. And so my common difference all the way through is 3. And if you notice, if I have a common difference that's always the same, that's going to be a linear generated sequence. And so in this case, I can write the equation for this generator by doing y equals mx plus b. If you notice, the first cell I got a 2, second cell I got a 5, third cell 8, and so on. And so what I want to look at is just writing equations. So I can just use these two right here. So I can take 1, 2, and write an equation based on this right here. So I'm going to take 2 for my y coordinate is equal to m times my x, which is the 1, plus b. That's one equation, two unknowns. To solve this, I need two equations, two unknowns. There's another way to do this too, but this is one way to do this. So I can go 2 and 5. And so 5 is equal to m times 2 plus my b. So now I have two equations, two unknowns. So I can solve for those. I'm going to pause and do that. You can try solving for those too. So I simplified the equation, wrote this as 2 is equal to m plus b, and then this one 5 is equal to 2m plus b. Since I want to do elimination and eliminate one of these variables, what I'm going to do is I'm going to subtract the two equations. So when I subtract 2 minus 5 gives me a negative 3, and m minus 2m gives me a negative m. So now I've solved for one of the variables, which happens to be my m. So m is equal to 3. Oh, slope is 3. Oh, yes. That's the same thing as what we have right here. We're going up and over, so we're going over by 1 and up by 3. So that would give me a slope of 3. Now to solve for my b, what I got to do is I got to take this and back substitute into here. And I think you can see quite easily that b is equal to, b is negative 1. So my generator for this equation would be, I'm running out of room here, sorry, y equals, what do I got now? 3x minus 1. But in our sequence notation, we go a sub n is equal to 3n minus 1. This would be my sequence formula that I'd want there. Okay, so now what we're going to do is we're going to look at other defined functions and try to figure out how to write equations for those, or I should say sequences. So if I look at this sequence right here, I have a 2, 5, 10, 17, 26. I hope you understand that that's not a common row difference. And so what I have to do is try to figure out what I end up with. So I'm going to do the row differences anyways. And when I do my row differences, I get a difference of 3, 5, 7. Oh, there is a pattern there. Now, if I go one deeper, what happens if I go another row? Well, I can tell that this is a difference of 2. This is a difference of 2. This is a difference of 2. This right here tells me I have a second row difference pattern. And what that means is, and you count one difference, second difference. Don't count the original when you're dealing with these. If I have a second row difference that's always the same, then what happens is that we're going to have something that's called a quadratic generator. So instead of having a linear generator as we did up here, we're going to have a quadratic generator. So here we had two equations, two unknowns that we had to deal with. Well, with a quadratic generator, we're going to have three equations, three unknowns. Oh my. So we're going to have to figure out how to solve for that. And then once I do that, well, I'm not going to tell you if we will have a shortcut, but we'll have a shortcut. Okay, so if we want to set this one up, what I do is I set this into a t-chart so I can see each one of these values. Since I need three equations, three unknowns, I'm going to use these first three terms. So with the quadratic, I just use the linear, I use the first two. Quadratic, I use the first three. And I'm doing this with the computer, so I'm not writing this out just because it's a lot neater if I do it with the computer. So To write the first equation, I'm going to take the point 1, 2 and plug it into this quadratic formula. So what I do then is I take 1, 2 and I plug it in. So this is my y coordinate, which is equated here. And then wherever I see the x, I'm going to put in a 1. That would be this x. And I put it in there and I put it in there. So now I have one of my equations to deal with. So now I'm going to take the second point and write an equation with that. And it's kind of weird that you're taking and putting in the x and y and leaving the variables a, b, and c, but that's what we want to solve for. We want to solve for a, b, and c. So if I do this, I'm going to plug in 2 and 5, and I get this equation right here. Now we're going to use elimination of one of the variables. And so we're going to eliminate, well, these have a different coefficient, these have a different coefficient. C has the same coefficient, so I just have to subtract the two equations in order to eliminate the C. So I want to break this down. 3 equations, 3 unknowns, break it down to 2 equations, 2 unknowns. Once you get 2 equations, 2 unknowns, then you can solve for one of the variables. So that's what we're doing. So if I subtract these 2 equations, 2 minus 5 is negative 3. 1 minus 4 would be negative 3. And then 1 minus 2 would be negative 1. So if we look at that, we get negative 3 is equal to negative 3a minus b. So that's 1 equation, 2 unknowns. So I have to do this again to get another equation with 2 unknowns in it. So that's what I'm going to do now. So instead of taking the first 2, I'm going to take the second pair and the third pair and put those 2 together in another equation. So I got 1, 2 already written, and I got 3, 10. So I'm going to write the equation, quadratic style, 10 for my y is equal to a times 3, that's the x, quantity squared, so this is 9a, this is 3b plus c. And I'm going to do exactly what I did over here. I'm going to eliminate c. So I'm going to subtract both these equations. This would be a negative 2, this would be a negative 8, and this would be a negative 8. So that's what I end up with. So now I have 2 equations, 2 unknowns. You've done this in Algebra 2 so many times. So I'm going to take these 2 equations, set them up as far as trying to eliminate them. Oh, and to eliminate them, I have to get one of the variables to be the same. So here I had negative b and a negative 2. So I got to multiply both equations by the top equation by negative 2 in order to eliminate this b. So if I take this equation and rewrite it, I'm going to rewrite it right under here. So now it's just these 2 equations that I'm dealing with. So this one in yellow is just a regurgitation of this one right here. So if I subtract those 2, I'm going to get negative 2 is equal to negative 2a. You should be doing this algebra by yourself, but I'm just showing you, and then I get a is equal to 1. Once a is equal to 1, now you can go and back substitute. I'm not going to do this for you, you can do it. Take the a and put it back here, and then you can solve for b. And when that happens, you're going to get b equal to 0. Now you got a and b, now you can back substitute it into maybe this equation right here, and then you should be able to get a, b, and c. And if you solve for that, you get c is equal to 1. You're going to have to check that algebra. You're going to have to do it in your homework, so you should be doing this on your own. So is that the answer? Is that it? No. We are looking for the quadratic generator, so we have to write this in sequence formula. So let's put a, b, and c into our equation, and we get this right here. Y equals ax squared plus bx plus c. I put in the 1, I put in the 0, I put in the 1 from all this information right here, except for this is not sequence notation. This is sequence notation, so instead of using x, I'm going to use n. And then I have a sub n as well. So this would be your answer here at the very end. Okay, so that's what we're looking at. All right, so 3 equations, 3 unknowns. Now, there is, and I needed to show you 3 equations, 3 unknowns, but there is a shortcut to this. You can find a straight away. Maybe you've already looked at this in class, but you can find a pattern and find out what A is. So let's look at some quadratic generated formulas and see if we can figure out a pattern for whatever happens to A. Well, I'm going to go back in time for 1 second. This is a little spreadsheet I put together. And so if I did, this is linear. And so I did y equals mx plus b, but I used a and b, so it might mess you up a little bit. But this is your slope, and this is your y-intercept. And so what happens is that this is the exact sequence that we just had. Now look at the row differences. Okay, the first row difference is all 3's. So if I go, and so that just shows you what happens. I can type in and plug in a different number here. I can plug in 4. Oh, look at the row difference stays the same because the slope stays the same. What happens when I change the slope? Oh, 5 slope. Oh, look at that. Row difference is 5. Nice. So you should have discovered that before, hopefully. Now with a quadratic, so now this is a random quadratic generated formula. So what I'm doing is I'm taking the coefficients A, B, and C, just like we just found, and putting it into this quadratic generator. This should be an n, I guess, up there. So if I look at this, n is 1, 2, 3, 4, 5. Those are just your locker numbers. T sub n is your values. So I'm going to end up with -1, 4, 13, and so on. Now look at this A value. And look at this second row difference. Notice the second row difference is always the same. So it is quadratic generated. And so this A is a 2. Now let's put in the 1 like we, oh, look at what happened. Okay. And then we put in the 0. And then we put in, the other term was a 1. So this is the sequence we were just looking at. 2, 5, 10, 17, 26. Second row difference is a 2. So now let me change this to 57. What happened to the row difference? Oh, it's still 2. Does it matter what happens to those B and C's as compared to the row difference? No. This is 2. This is 1. Now let me put this as a 2. Let's see what happens. Anybody want to conjecture? Yes, a 4. Nice. Okay, so what happens is that we can do a shortcut by finding A right away. What happens if A is 3? Let's see if this still works. Oh, second row difference is 6. So if we can find the second row difference, that would be a shortcut to finding out what A is. If we do that, then we can straight away have 2 equations, 2 unknowns to solve these things. So I'm going to show you an example here in a second. Let's plug in one more. 17, what's the second row difference going to be? 34, yes. So I'm going to work this backwards now. I plugged in a specific A, B, and C to generate this sequence, but we're going to pretend that we don't know this, and we're going to try to solve for that. So we know that A would be 3, B would be -1, C would be 4. That should be our final answer. So let's show how to solve this. So if I take this sequence, and you can put this on your notes now. So here's my example that you can write down. So if I'm given this sequence, 6, 14, 28, 48, 74. Given that sequence, I want to find an explicit rule for A sub n. I've been calling it a quadratic generator, but really these are explicit rules. So either way that we ask the question, that's what we're doing. So what we know now, instead of doing 3 equations, 3 unknowns, we have a trick up our sleeve. We know that this let me do this first, sorry. This right here, this would be a difference of 8. Let's find the common differences. This one would be 14. This one would be 20, and whatever that is. Okay, so then this one would be 6, and this one would be 6. This one would be 6. So this would be 26. All right, so then my second row difference is always 6. Well, the shortcut that we just figured out with that spreadsheet is that this 6 is equal to 2A. So 2A is equal to 6, A is equal to 3. Wow, is that easy? I just found my A term straight away. Now I just have to go find B and C for that right there. So that should be 2 equations, 2 unknowns to get this set up. So I'm going to write this out, and then you can do some of the algebra with it. So pause. Well, I'll try it. So I wrote my 2 equations. I took a point, I took another point, and I wrote the equations out for those. Oh, look at this. Instead of putting an A, I put the 3 because I already know it. I already put the 3. So I'm going to clean up these equations, and then we can solve for 2 equations, 2 unknowns. So hopefully you tried this too. You should be pausing this and trying some of this yourself. So I took this equation, simplified it out. So I got B plus C is equal to 3. That's what the first equation is equivalent to. Then the second equation, I simplified that out to here, and then I got this right here. So now I have 2 equations, 2 unknowns. I can eliminate the C by subtracting the 2 equations. 3 minus 2 is 1. B minus 2B is negative B. So B is equal to negative 1. I think if you remember, that is what we wanted to get. So now we back substitute to go ahead and find out what C is. And so when I do this, I plug in negative 1. 3 is equal to negative 1 plus C. So C is equal to 4. So for this pattern right here, I get a second row difference of 6. We know that A is equal to 3. And so we get A sub n is equal to 3n squared minus n. I don't need that 1 in there, but I put it in there for effect, plus 4. And the spreadsheet, oh, voila. Same exact thing that we generated the sequence from. All right, so I hope you saw a lot of connections here. Put a lot of this stuff together. This video is a little bit longer than I wanted, but that's how it goes. Have a great day and enjoy row differences.